We'll give everyone a moment to shuffle in, and I'll try to catch names as they fly across the screen. Some names are new to me, some names I have seen before. I see Evan, I see Alexa. Hi, everybody. Let's see who else. Oh, Clifford, you're here again. Good to see you. I'll virtually see you, Ken. And again, everyone's names, if I don't say your names because you flew off. Dan Brian Lewis, good to see you, or virtually talk to you at least. Always fun to have you around. Hope you're doing some good mushroom hunting. For those of you who don't know, Brian Lewis is our mushroom aficionado. He gave a whole talk at the R conference about using Shiny to identify good mushroom patches. It was really awesome. Let's see who else is coming in here as we go. And again, if I don't say hi to you, it's because your name flew by. Oh, Paul Pulio, good to see you. All right, a bunch of people shuffling their way in. Hope everyone's having a lovely August, wherever you may be. And I imagine we have mostly Northern Hemisphere people, so hope you're enjoying your summer. If we have any Southern Hemisphere people, hope you're enjoying your winter. I know sometimes we do get people from, below the equator, and we get people across the prime meridian also. We get people from all over. And of course, this is recorded, so people can watch it anytime they want later at their leisure. So everyone's sort of coming on in, and we'll get started in just a few moments with our announcements. In fact, I will pull up our announcements as soon as I find them. Great. So, all right, I'll get started with just a few announcements, and hopefully by then, everyone will be here to join in on the talk. Okay, so again, welcome everybody. This is the August meetup in the year 2 of the pandemic. Just when we thought things were looking up, things might be stretching out a little bit. So those of you who have attended in person, or those of you who have even been here for the virtual ones, know I always like to start the meetup by asking who is hiring. Unfortunately, I can't have everyone jumping up here and shouting who's hiring because it's just the webinar platform. So if you are hiring, you want to hire somebody, go to the NYHackR Slack. I believe we'll be able to post a link to get there. It's nyhackr.org/slack.html. There's a link there. And we have a channel called Job Postings. There's been a number of postings on there. I know throughout the meetup, throughout the past 10+ years, a lot of people have gotten jobs through the meetup. So I hope people continue to get jobs through the meetup. I know just Noam Ross, one of the sponsor for today's meetup, posted just a few days ago about a job he's hiring for. So if you're looking to hire, you might have posted for 2 jobs. If you're looking to hire, please go to job postings and post your job on there. And let's get people for the meetup a job. You're going to find lots of great people. Since I have the benefit of actually being on camera, I will tell you that I am hiring both full-time and part-time. We're looking for someone to do technical sales, an account executive role, but it's good if you know about R, Python, Shiny, RStudio, Jupyter, stuff like that. It's good to have technical chops in a sales role. We are hiring a data scientist. We're hiring a Shiny developer and a Linux sysadmin. So we have 4 roles open. Only one of them is up on our website. We will get more up on landeranalytics.com/careers in the next few days because we have a few roles we're hiring for, and I will get them all posted up there. And we'll also post them on the job postings channel, as I encourage everyone else to do. And I see someone already posted. That worked awesomely. Thank you, B. Carlson. So I just saw the username. Thank you for posting. It wouldn't be a New York Open Statistical Programming meetup without pizza. So mine today, the tip just broke off. So mine today is from, it's not a bite, I swear. I wouldn't hold up a bite pizza. Here's the tip, everybody. All right. Mine is from a place called Nomad. It's been sitting at my home for just about 15 minutes. So, the cheese lock is in there, but as a good Neapolitan pie, it had good cheese lock out of the box and it has some good charring on the bottom as a good wood burning place should. I hope everyone else has good pizza or other snacks to keep you full during this talk. I so miss having pizza of everybody and having the pizza poll. Hopefully soon, one day we'll see each other and we can have pizza together and other things. So I hope everyone has good pizza wherever you may be, or again, other snacks if you want to have an inferior food to pizza. It's up to you. That's cool by me. So our next meetup, we are not quite ready to announce the speaker yet, but it will be September 1st or 2nd. All right. Stay tuned for that. We'll have an announcement coming up soon at meetup.com/nyhackr. We will tweet it. We'll put it up on Slack. So September 1st or 2nd, we're going to have our next meetup. It will be virtual, just like this one. I know in the past we talked about making September in person, but even before COVID started getting worse, it was tough to find companies that were ready to host someone on September 1st because they were opening their offices in September. I don't think they're even doing that anymore. So stay tuned for September 1st announcement. Also in September, the New York R conference is back. We have workshops September 1st, the week before the conference, to avoid conflicts with Labor Day and Rosh Hashanah. We're hosting it on September 1st. We have 6 workshops. I'm going to forget some people, but we have Max Kuhn, Kaz Sakamoto, Dan Chen. We have Malcolm Barrett and Lucy D'Agostino, and I'm forgetting Lucy's last name. You have Jeroen Janssens, and I think we have one more. I said we had 6. I'm forgetting one. I apologize to every person I'm forgetting. We have one more. That's September 1st. You can find out more at rstats.ai/NYR. Then the following week, September 9th and 10th, we have the New York R conference. This is the 7th year. Been going strong for a long time. Currently, it is still planned to be both in person and virtual, though every day we have long discussions monitoring what's happening. And if we need to make the switch to virtual, we will let everyone know, and we'll hold it completely virtually September 9th and 10th too. We're ready. Unlike last year, we know what's happening this year, so we are ready to go if we need to switch over, and we're doing virtual component anyway. So stay tuned, and don't worry, if you bought an in-person ticket, we'll switch you over to virtual. Don't worry about that. Hope a lot of you can attend. It's 2 of my favorite days of the year, to be honest. It's just really great. We have great speakers here, some repeats, some new. We have, mainstays like David Robinson, Max Kuhn, and Wes Mckinney. We have newcomers like Ozma Toomey, Jeroen Janssens, and Caitlin Hudon. We have a lot of good people speaking. We have 24 speakers lined up. Again, if you want to learn more, go to rstats.ai/NYR and check out the workshops, the speakers. We have a whole agenda up there. It's going to be a lot of fun. If you're buying tickets, the code is NYHackR. And I see Nicole posted the link and the promo code to the chat here on Zoom. Get a 20% discount on any of the tickets, the workshops, the conference tickets, using code NYHackR. So go check it out. I see Steven's very excited to attend. I'm excited for this conference. I really do love this conference so much. I'm really excited to be there. If your company is looking to sponsor, either to, because you have cool open source stuff you want to show, you have cool products you're looking to hire, contact us, get in touch with me, get in touch with Nicole. You can find me on Twitter, on anywhere. I'm very reachable through the websites and everything. For more information about the meetup itself, visit nyhackr.org. We have 11 years worth of slideshows up there and probably about 8 years worth of videos. There's a lot of good content up there. The site, as I said before, is poorly designed, so it needs to be rebuilt, but it's all open source and it's on GitHub. So make a PR if you think it's ugly, because I designed it and it is ugly. I admit it's totally ugly. All right, since we can't ask questions of Ian directly, what we're going to do is I'd ask anyone who has a question to please post it on Slack. There is a channel called Monthly Meetup Chat. Go in there, post your question, and I will collate all the questions. And at the end of the talk, I will grill Ian with the toughest ones you have. All right, make it hard, try to stump him. Let's go deep on this one. So again, that is in Slack, Monthly Meetup Chat. I mentioned it in passing. I just want to thank EcoHealth Alliance for supplying the Zoom for us. They've been supplying the Zoom link for us since the first month of the pandemic. And thank you very much, particularly to Noam and Emma, the 2 people there who really have our backs at this organization. They've been helping us out this whole time. So just a little round of applause for them helping us out. I'll do a little virtual golf clap to thank them for that. So hope everyone had a fun time. Remember, next month, we have a meetup, we have workshops, and the New York R conference. So I am super excited for that. And we will keep you posted what we're doing based on CDC and New York City guidelines. All right, we will keep everyone posted about that. So with that, I am very excited to introduce Ian, who's going to give a talk about a package or a few packages that I am personally very excited about. They're really cool. I'm not going to talk it up too much. So everyone, please welcome another round of golf clapping for Ian.
Thanks, Jared. I'm excited to be here. So when Jared asked me to speak, I was working for a company called Ursa Computing, which is a startup company founded by Wes Mckinney, who I think many of you know as the creator of the Pandas library for Python. So the mission at Ursa Computing was to accelerate applications of Apache Arrow But since then, Wes and the team at Ursa have joined forces with some other pioneers of the Apache Arrow ecosystem, especially some folks who are working on sort of GPU accelerated data science. And we formed a new company called Voltron Data. And our goal now is to create a unified foundation for the future of analytical computing that's optimized for like diverse hardware, so CPUs, GPUs, and beyond. And it's compatible across languages and fast and efficient. And again, all based on Apache Arrow. So I'm excited to be part of that team. We are also hiring, so I'll show you at the end the link to go to. But today I will be speaking about these two R packages that I created before joining Ursa or Voltron, tidyquery and queryparser. So these packages sit at the intersection of SQL and R, as do a few other packages that I'll mention. But also sort of broaden this topic to speak more generally about what you might call syntaxes for data manipulation, or data interface languages, effectively like the human interfaces to data through code that we all use. So SQL is one of these. In R, there are several, right? There's Dplyr, there's data table. If you like to inflict pain on yourself, there's base R, of course. And in Python, there's pandas, and other languages have others. So, tidyquery and queryparser are just one example of this like broader trend toward decoupling those interfaces or front ends from engines or back ends. So I'll describe some history of how we ended up in this like scientific and statistical computing community with interfaces that were tightly coupled to engines in the first place. But then how in the last 5 years or so, there's been a trend toward loosening those couplings. And then toward the end of the talk, I'll lay out a vision for kind of where that trend might lead. And I'll describe some work that the Arrow community, as well as some of us at Voltron Data, are doing to realize that vision. But actually, I'd love to start first with a poll question. And I have a link that I want to share, but suddenly I cannot see the chat. So I'm going to stop sharing for 1 second and paste that link, and I'll start sharing again. And I believe Nicole is going to repost this in the Slack. So there's a Slido link that should take you to a poll. All right, and I'll start the poll. And the question is just, do you know SQL? So, since this is an R meetup, I'll assume like almost everyone here knows R and uses R, but I'm curious to know about familiarity with SQL. So, if you have any experience with SQL, at least a little bit, some familiarity, you can answer yes. So I'll just wait 1 minute for folks to answer. But it looks like, yeah, unless things change dramatically, the vast majority, almost everyone, in this crew knows some SQL. And this is consistent with like what I've seen, anecdotally, and what some of the evidence from things like the Stack Overflow survey results, like Stack Overflow developer survey results, bears out. So there's one more question. Which did you learn first, SQL or R? So at that same link now, that should have changed. So there's a second question being posed. Which did you learn first, SQL or R? So I'll give you a minute to answer that. All right. So this is kind of a split pretty evenly. A lot of people learned R first, as you might expect in a crew of statistical computing nerds. But almost half learned SQL first. So I don't know if there's any evidence on this, but anecdotally, I've seen it to be the case that a lot of people learned SQL before R in the broader community. But it seems like maybe 40-some% of this crew has. But yeah, a nice split there. So if you know some SQL and you know the tidyverse and R, I mean, one of the things you'll know is that SQL and Dplyr, the sort of centerpiece of the tidyverse, although they have a very different syntax, when you look at them more abstractly, they have a lot in common. Just 1 second. My cursor keeps disappearing on me. Okay, so the tidy, so yeah. Next slide. So first of all, both Dplyr and SQL databases generally require that you organize data in a certain way in order to work with them. So the tidyverse has this set of rules, for how you have to organize your data. Each variable forms a column, each observation forms a row, each value typically has its own cell, and then each type of observational unit forms like a table or data frame or tibble. And again, in the tidyverse, we call that tidy data, and it's how you need to structure your data in order to work with it with Dplyr. But in the world of SQL and databases, essentially those same rules are the essence of normalized tables in a database. So then once you have your data in this kind of structure, regardless of whether you call it tidy or third normal form or whatever, generally the types of operations you would apply to that data are roughly the same in Dplyr as they are in SQL. So Dplyr, of course, provides this set of functions or verbs, with the idea being that you can just use a few of these verbs to do most of the kinds of data manipulation that you would ever need to do. Dplyr was created by Hadley Wickham, as I'm sure you all know. And when Hadley created it, he more or less brought the semantics of the SQL select statement to the R language with just a few changes, and of course using the syntax of the R language. And if you're not familiar with SQL, the SQL select statement is what you use to query data in the SQL language. So when we say SQL query, we're typically talking about the SQL select statement. So a select statement never modifies data in place. It retrieves the data and effectively makes a copy of it and then manipulates that copy and then returns the result. So, let's look at how SQL compares to Dplyr. So Dplyr has verbs. The SQL select statement has clauses, and there's 7 main clauses in the SQL select statement: select, from, where, group by, having, order by, and limit. And each of these maps on to a Dplyr verb, although the mapping is not exactly like a clean one-to-one mapping. So I'll go through this. So first of all, the from clause specifies which data frame or table you should retrieve the data from. That in SQL maps to just simply the name of the data frame, which you would use like at the top of your Dplyr pipeline. Moving on, the select clause in a select statement maps onto like a few different constructs in Dplyr depending on what you're trying to do. If you are just retrieving existing columns out of a data frame or table, well, that's just the select verb in Dplyr. However, if you are mutating columns, you're using expressions to define new columns, that's mutate in Dplyr, or transmute if you prefer. And then lastly, if you are computing aggregates using aggregate functions, sum, count, max, stuff like that, then you use summarize in Dplyr. The where clause, which filters rows, maps to filter in Dplyr. Group by directly maps to group by. Having is in SQL, it does filtering, but it does filtering after the grouping and aggregation. So Dplyr has simplified things and just reuses the filter verb for this, but after group by. And then order by corresponds to arrange in Dplyr, and then finally limit corresponds to head or slice. And so that's roughly how you map SQL onto Dplyr, or the arrows could be going in the other direction. But it's not just Dplyr that has modeled itself in this way, like on some of the same underlying abstract ideas as SQL. SQL has been like really influential, such that many other systems, Pandas, the Spark Data Frame API, all follow the same semantics, but just to varying degrees. Dplyr and the Spark Data Frame, for instance, kind of holistically adopted this SQL abstraction from the start, but others like Pandas gradually adopted certain elements of it over time. So incidentally, I'm not really going to talk about much besides R and SQL in this first part of the talk, but if you're interested kind of in understanding how Pandas would map on to this sort of mapping right here, I gave a talk at a local Python user group meeting a couple of years ago. One second. And there's a repo, there's a repo here enmcook/dplyr-pandas on GitHub, where there's some slides that kind of explain how you could also map pandas data frame functions to dplyr verbs, and how you can, if you wish, use pandas in a dplyr-ish sort of a way. So take a look at that if you're kind of interested to understand how this mapping extends to pandas. So one of the cool things about having this common abstraction that underlies both SQL and dplyr is that it enables dplyr code to be translated into a SQL select statement and used to query a database. And as I'm sure many of you know, that is exactly what the dbplyr package does. So with dbplyr, you connect to a database, you refer to a specific table in the database, and then you chain on dplyr verbs, much as the same as you would if it was a tibble or a data frame that you were manipulating. And dbplyr translates all of those dplyr operations into a SQL select statement. Sometimes it does that with the help of a custom dbplyr backend package, and then it runs the resulting SQL select statement on the database, and it uses the dbi package in R to do that. So I have an example of this I will show you just a moment. All right, let me increase the size of this. Yeah, so this is, I mean, if you haven't seen dbplyr, this is how it works. You load some data, and I'll be using for a lot of these examples the NYC Flights 13 data set. And then you load dplyr. And then what this line does is it copies the data out of the data frame, the flights data frame that comes with NYC Flights 13 into a database table in this embedded SQLite database that comes with dbplyr. But you can also use like any other database that's supported by dbplyr or various backend packages for it. It's just that SQLite is kind of the easiest way to do an example without having some external database that you're depending upon. So I'll run that. Whoops. I think I already ran it. So it told me the table already exists. And then you run a dplyr command and you get the result. And so under the hood, what is happening is that dbplyr is translating all of these dplyr verbs into a SQL query. And one really cool thing about dbplyr is that it includes this function show query. So if you append that onto the end of your pipeline here, you get not the result set, but in fact the SQL query that it runs to generate that result set. So that's a pretty neat feature of dbplyr. Okay. So I've been using dbplyr for a few years, and I authored a custom backend package for it for Impala a few years ago, and I've made a few like contributions to it also. But around 2019, I got really curious about going in the opposite direction. So converting SQL to dplyr, so that you could, say use a SQL statement to query an R data frame. So at the time I was working at Cloudera, and I was creating a series of Coursera courses about SQL. So basically I was like neck deep in SQL for over a year. And then we launched the courses, and I was like looking for an R side project to work on. So it seemed like a natural fit. And so, but I didn't want to reinvent the wheel, right? So I looked around and saw like, are there any other packages that convert SQL to dplyr? And there were none. I didn't find anything, but there is a very popular package that does something similar, and it's the SQLDF package created by Gabor Grothendieck. So let me show you, if you're not familiar with that, how this works. So when you have some data loaded in a data frame in R, you can load this SQLDF package and then call the main function in it, which has the same name as the package, SQLDF. And that function, what it actually does under the hood is it does not parse your SQL statement or really understand much at all of what the SQL statement is asking in terms of data manipulations. Instead, it sets up a database transparently to the user, sets up a database that's embedded inside R. It's an SQLite database. And then it loads the data from the R data frame into a table in the SQLite database. And then it runs your SQL query on the database and then returns the result as an R data frame. So that's kind of a neat trick, and it's become an extremely popular package. It's been around for a really long time, and there's like lots of people who use this. This is something I saw a lot working as a data science educator, is that a lot of users who come to R, they're really interested in doing a lot of sort of higher value tasks with R. They're interested in machine learning, the data viz, Shiny, stuff like that. And they're somewhat dismayed to have to learn a whole new syntax for data manipulation if they already know SQL, just to sort of prep the data for those higher order applications. So those users are often really sort of enamored with this ability to just run SQL queries, use SQL to manipulate data in our data frames. But there's some limitations of SQLDF it's important to recognize. Like I said, it works by copying the data out of R and then into this database. And this works pretty well for smaller data. It does introduce some latency, especially on the very first query for a particular data frame, because it has to like copy that data out. But it's pretty well optimized actually, and subsequent queries are like pretty fast. But if you have a really large data set, it starts to slow down a lot. And also just kind of architecturally speaking, like copying data to a different system is a bit of an anti-pattern. There's the serialization, deserialization cost. There's the potential like loss when you're converting R data types to SQLite data types. So not exactly the architecture I was looking for. So I set out to create something a little different. And I realized that this problem kind of broke down into two parts. The first part was parsing the SQL query into some kind of like abstract representation of all the data manipulation steps in it. And then the second part was actually applying those data manipulation steps to an R data frame. This really turned into two packages, not one. And the first one, named queryparser, is on CRAN and GitHub. And I will confess that like when I first set out to do this, I dramatically underestimated the challenge of solving this first problem. But I did manage to do it with some limitations. So let me tell you a bit about more about this package. I keep losing my cursor, so hold on one moment. Got it back. All right, so let me actually go to an example before I tell you how it works. So the main function in queryparser is named Parsequery. So what it does is it takes a quoted SQL select statement as input, and then it returns, well, let me show you, I'll run it. What it returns is a structured list that sort of has a structure similar to the structure of a SQL select statement. So you can see this has a sublist named select, another sublist named from, and so forth, group by. So sublists that, that are named for the different clauses of the SQL select statement. And then inside the sublists, each SQL expression is translated to an R expression. And if you include this option tidyverse and set it to true, then in addition to taking advantage of like base R functions, it will use tidyverse functions like functions in Dplyr and a few other of the tidyverse functions, tidyverse packages. So there's also a few attributes such as whether a given whether the query or a given set of expressions like aggregates or not. So, but what these expressions are, they're unevaluated R expressions. So they're quoted or diffused or unevaluated R expressions. So there's a few things that are kind of cool about this query parser package. One is that it is implemented entirely as R code. So there's no imports, there's no depends, there's no C++ code, there's no like external query parser. It's just R code calling base R functions. As I said, there is this option to emit tidyverse functions, but it doesn't actually depend on any tidyverse packages. Another thing that's kind of cool about this query parser package is that I wrote it to perform semantic translations, not like literal translations. So for instance, one of the things you see sometimes people do in SQL is they use sum of one to compute a count of the rows. This is exactly the same thing in SQL as count star. But in Dplyr and R, if you do sum of one, you will not get that result. It will not like accumulate one over all the rows. You'll just get a one out of it. It treats one like a scalar. So what query parser does is it translates this semantically into like what your meaning is, which is the number of rows times whatever scalar you put inside, which is one in this case. Another neat thing about query parser is that it prevents you from running dangerous functions. So, I imagined when I was creating this that someone would eventually like expose the SQL interface through like a publicly accessible shiny app. And I didn't want someone's system getting hosed when a user cleverly included something like this in the SQL query that they're posting. So it actually has a list of all allowed functions and operators and everything, and it checks your SQL query against that list and only allows functions that, it only allows queries where all the functions are on that list. Okay, so the details of how this works are kind of complicated and beyond the scope of this talk, but here's just like a rough sketch of how it works. First, it splits the query into all those clauses. Then it splits the clauses into strings that contain each of those kind of expressions that exist. Then here's where it gets a little like messy. It does a bunch of string manipulations to change SQL strings into things that pass as R expressions, so that the R like expression parser will recognize them as valid expressions. This is sort of a deeply unsatisfying and hacky part of this process, but it was much easier than trying to like model the entire syntax of the SQL expression language. Then the R function stir2lang is used to parse those expressions into actual unevaluated R expressions. Then sort of the heart of query parser is this whole bunch of steps that happen in the middle where the expression is unquoted, values are substituted in, and then it's deparsed, and we do some additional string manipulations and then reparse it. There's just a whole series of very complex steps that happen. It's a bit of like a Rube Goldberg machine, frankly. Not a super elegant design in the middle, but it does work. And then finally, the resulting like abstract syntax tree, the unevaluated like R expression, is manipulated a little bit, checked for validity, and then returned as that object that you saw, that list that you saw. So that's more or less how it works. It's kind of slow at doing all this. It takes maybe 100 milliseconds or up to like a couple hundred milliseconds for a more complex query. So this is really slow. Like this would be unacceptable in the world of like high performance databases, but if you're just running a single query, like it doesn't add noticeable overhead to the time it takes to run like a single Dplyr query. So feels more or less instantaneous, even though it's rather inefficient, computationally. Okay, so moving on to the next piece, tidyquery. This is the package that, as an end user, you probably use most often. It would be pretty rare that you would want to make direct use of query parser. So let me go to an example of tidyquery. Lost my cursor. Okay, got it back. So the main function in tidyquery is named query. So I will load the package, keep that NYC flights 13 data. And so you just call the function query and you pass to it a SQL select statement. So this really works much the same way. I mean, to the end user, the interface is much the same as SQL df. You just have a function that you simply pass a SQL select statement to, and then it returns the result as a tibble or a data frame to you. And it does this by, let me go through how it does it in a minute, but there are some other ways to use it though. Another thing you can do is kind of use it as a, let me show this way. If you leave the from clause out, so let me get rid of from planes and instead put planes at the beginning and then pipe planes in, this works too. So you can take the data and pipe it in, and this allows it to be like used in a Dplyr pipeline. The only thing is you need to leave the from clause off, because now where the data comes from is defined by the first argument. This opens up the possibility of doing this kind of stuff where you just use query as if it was another Dplyr verb. So you can filter, you can arrange, but say you just really don't like summarize for some reason. You don't like group by and summarize. Cool, just do that stuff in SQL, and that's what happens in this step. So you can just pipe it on to other Dplyr verbs. So let me explain how this works a little bit. So the first thing that this query function in tidyquery works, the first thing it does is just simply call the query parser parsequery function and get that list that I showed you in the previous step. And then it has to do some work to determine like what sequence of Dplyr verbs to call, and pass those expressions that are in that list too. So then it uses Dplyr together with rlang to do a bunch of that similar sort of quasi quotation, unquoting, quoting, substitution work to evaluate all those expressions in the context of the data frame, and then it returns the result. So, whoops, I'll get back to that in a second. So one really cool thing about so before I get to that, let me just show that there are some limitations of tidyquery in terms of what SQL it supports, but it supports all these main SQL select clauses, and it can take some pretty complex queries. So it deals with joins. It deals with expressions like is not null and between that sort of don't map directly to any sort of base R syntax, and so the full complement of your basic like SQL select statement clauses it works with. I'll talk about the limitations in a minute. So, but another really neat thing is that your data doesn't have to be in a data frame for this to work. It just has to be in some object that Dplyr can be used on. So for instance, Hadley a few years back created this Dplyr package, which exposes a Dplyr interface to the data table package. So if I load that and I take these two tables used in this complicated query here, flights and planes, and I change them into data table objects through this lazy DT function, which is part of Dplyr, then I can run the query, but it's not running it on a data frame, it's running it on a data table, and it generates the same result. So it's, this allows you sort of in a way that SQLDF doesn't, it allows you to run on anything that has a Dplyr interface. And I concocted some circular examples that generate a SQL query and then parse it and then generate the Dplyr and then parse it to generate the SQL query. You can use dbplyr and tidyquery to just generate like a circular process of queries, which is pretty wild. But it actually works. And generally, tidyquery will emit it will generate Dplyr that is like pretty clean and optimized. So one other cool feature that I want to show you about is that if you want to not run the SQL query using Dplyr, but just see what Dplyr it generates, there's a function show Dplyr that's part of tidyquery. So you run that, and then instead of giving you the result, it gives you the Dplyr pipeline that it uses to generate the result. So it translates the SQL into this and then just displays that. So it's sort of the reverse of show query in dbplyr. So that, I like this because it enables tidyquery to be used not just as a means of querying a data frame with SQL, but also as a means of taking your existing SQL skill and using it to learn Dplyr skill. That was part of my motivation for creating this. So some limitations that it's important to mention. Currently, query parser and tidyquery do not support subqueries. That one is probably the biggest omission right now that I would love to work on. I've been kind of busy lately and haven't had a chance to do it. But certainly, if anyone's interested in collaborating please reach out through GitHub, or my email address is in the slides here. And it would be neat to get some collaborators to help with this. A few other things: it doesn't support unions. That's pretty straightforward to implement. I just haven't done it yet. SQL 89, or implicit style join notation, where the join conditions are in the where clause. It doesn't support that because sort of disentangling what is join conditions and what is filter expressions is quite difficult. It does support the so-called SQL 92 or explicit join notation, and that's the examples that I showed before use that. It doesn't support joins of 3+ tables. When I created it, it was actually impossible to support those generally because of some ways that Dplyr joins didn't quite match SQL joins, but Hadley has done some rewriting of Dplyr since then, so I think it should work in theory now. And then a couple of these other sort of more sophisticated things in SQL, like the with clause or common table expressions, doesn't support that yet, but it in theory could. And then window or analytic functions with the over expressions, it does not support that either. So if anyone's interested in contributing to some of this functionality, I'd love to help you through that process. Or if there's something that's not on this list of limitations that you see that's not working properly, please report it. Love to get bug reports. There's lots of testing, but there's always things I missed. So love to hear bug reports. Okay, so now I'm going to kind of move to the second part of the talk, and I don't have a lot of slides on this. So mostly I'm just gonna talk, so as I said at the beginning, this work that I did was motivated by this idea that it would be cool if we didn't have each engine tightly coupled to its interface. It would be cool if we could use any interface to drive any engine. Users don't write code for engines; they write code for interfaces. And if you go like way back to the early days of computing with data, like before relational databases, the distinction between engines and interfaces was mostly moot because each interface was tightly coupled to an engine. If you wrote code for a particular interface, you were kind of stuck using that associated engine. And if the engine no longer met your needs, you were kind of out of luck. The only solution was to rewrite your code to use a different engine. Well, SQL came along, SQL, and changed this gradually. It didn't happen instantaneously, but over time, SQL kind of became one interface to rule them all in the database world. And gradually, any database that kind of wanted to play in the big leagues needed to make SQL its interface to tightly couple itself to SQL. And because SQL was so much more usable than most of the other data manipulation interfaces that were available at the time, this standardization on SQL really helped to accelerate the rise of data analytics. And also the abstraction underlying SQL, as I discussed earlier, has had a major influence on a lot of what's come since then. SQL, of course, is an ANSI and ISO standard. It's been revised and expanded several times. And although the language today has fragmented into a bunch of separate dialects, which are actually now sort of coupled tightly to specific engines, still SQL remains probably the closest thing we have to a universal representation of data manipulation operations today. But meanwhile, so there's some stuff going on in the database world there. But then as fields like scientific computing and statistical computing and data science sprung up, SQL and databases didn't gain as much traction there early on. And there's a lot of reasons for this. I mean, I'm not sure what they all were, but I think the declarative syntax of SQL, the lack of sort of standard facilities for extensibility and programmability, those were some factors. Kind of the rigid model imposed by relational database systems. They were a little at odds with the style of programming and languages like Python and R, and some of the other languages that were flourishing early on there. I think open source pioneers in the scientific and statistical computing communities, folks like Wes, when he built pandas, and the original developers of R, and then Hadley and Matt Dowell and folks after that who built other interfaces on top of R, wanted to create like richer syntax, more expressive, more easily extensible, more seamlessly programmable, more idiomatic for like users of that language. And so they sort of, at the beginning, like left databases behind in many cases and built things like pandas and Dplyr. And, again, early on, in particular, but still today, like pandas is an interface, but it has an engine underneath it and it's tightly coupled. So Dplyr early on was an interface, but in the early days before Dplyr, like the only thing that could do is power the Dplyr engine in R underneath it. So we were kind of back to this tightly coupled interfaces and engines. But then, like there's opportunity. There were opportunities here. It was clear to decouple, as I said, because the data. If you look at like the data manipulation operations that could be expressed in Pandas syntax or in Dplyr syntax, most of them could also be expressed in SQL. There are some exceptions, but at an abstract level, there is a high degree of overlap between these, these three interfaces and others, and their respective, and their respective engines. But another factor I think is that traditionally databases worked by ingesting all your data, storing it like in a proprietary closed binary format, and then mediating all access to it through the SQL interface. And I think in the early days, especially, this really contradicted the values of openness and extensibility and all this in the Python and R communities and, the broader statistical computing and scientific computing communities. Python and R like already had ways of representing data in memory, and those were different from the formats that the SQL databases used. One notable thing is that because the in-memory format that, say, that NumPy, which was sort of what came before pandas, used to represent arrays, was not the same as the in-memory format that SQL databases used to represent arrays or columns. There wasn't really a basis for sharing code between these different systems either. And then, so if you wanted to, say, take advantage of a SQL database in order to not have to rewrite all these same operations in Python or in R, well, then you need to deal with this like huge serialization, deserialization cost to move the data to another place. And then to make matters worse, like a lot of databases early on were row oriented, not column oriented. So really had a lot of bad performance on some of the sort of columnar type work that people were interested in doing in Python and R. So I think, many reasons for this divide. Another was sort of this persistent dogma early on that SQL engines run on servers, not on PCs. So this is another factor for sure. Although there were early on, like, I think projects like SQLDF, like I mentioned, there were early sort of examples of creating an interface that broke through this this tight coupling, even if the architecture of it was maybe not ideal. So this situation of sort of tightly coupled interfaces and engines persisted for some time, and it has some interesting consequences today. Like, we think of data frames and tables as different things, even though they're like mostly the same. Another effect of this is that like there's all this work that's gone on in the SQL and data warehouse community to like get really blazing fast speed out of query engines, and a lot of that didn't flow down to R and Python and languages like that because the communities were just so separate. Again, there's some exceptions to this. I mean, data table is an example of on both counts, right? They use the word table instead of data frame, and they brought like really good performance into R. So there's some exceptions. But around 2016 or so, we started to see like more of a convergence in this world. So this brings us to this diagram. So right around 2016, a bunch of exciting things started to happen. The kind of the wall between databases and data warehouses on one hand, and then scientific and statistical computing on the other hand, started to crumble a little bit. It started to be easier to interoperate between Python and R and other languages, thanks in part to projects like Apache Arrow that tried to create some standardized interfaces between them. And a bunch of other projects came out during this time. I mean, the work I did with tidyquery and queryparser was one example of this, but there's many others. I mean, Dplyr, I think that started in like 2018, I want to say. Maybe it was a little earlier. Originally, Dplyr didn't have a way to query databases, but then it was added as Dplyr. Well, first it was part of Dplyr, then broke it down into Dplyr. It's another example. In the Python world, there's a package called DataFrame SQL that was created. There's a few others. There were some multiple examples of attempts to port Dplyr or something Dplyr-like to work in Python on pandas data frames. So people started to be really interested in loosening the coupling between these things. Meanwhile, in the sort of data warehouse community, the Apache Spark project was really influential at changing some of this. It helped kind of accelerate like a convergence of the world of databases and data warehouses and Python and R and scientific computing. So PySpark, SparkR, and later projects like SparklyR and Koalas. Koalas is a pandas-like interface to Spark. I think these demonstrated sort of that there were ways to cross these language barriers and expose engines through different interfaces that they weren't sort of originally designed for. The problem with this is that as like all these projects grow, and there's even more sort of dimensions that I'm not, portraying on here. Like for instance, this whole, I mean, I'm just sticking to Python and R world here. So add in other languages, add in projects like around GPU computing and non-CPU based engines, and you just get this like massive combinatorial explosion of new innovations, which is exciting, but it's also kind of concerning. I mean, this diagram, just rapidly turns into like a terrible spaghetti bowl, and puts into question like the sustainability of some of these projects, and something really has to give. So there's multiple solutions to this problem, I think, but one that we're really interested in pursuing in the Apache Arrow community and at Voltron Data is this idea of making a general language agnostic compute intermediate representation, or compute IR, into which every interface could, that was interested in being compatible with this could write a compute IR representation, and every engine that was interested in being compatible with this could consume it. And so, for instance, Dplyr could generate compute IR, but then you could run on any engine that could consume it. So you could cross language barriers, you could send it to different cloud computing vendors, and so forth. And so there's been work that's happened here. I mean, like there's multiple projects where bits of this have been shipped off. Like some of the work that's happening in the Apache Beam project seems like some interesting prior art here, and there's others. But we in the Arrow community are thinking a lot about sort of how to solve this problem in a really truly language agnostic, kind of very standard way going forward. So yeah, so this is actually going to be the subject of a talk at the New York R conference. One second. So Wes Mckinney, who is the CTO of Voltron Data, is going to speak on Friday, September 10th at the New York R conference. And he's going to talk a little bit about some of the details of what we're hoping to achieve with that, compute IR, and some of the rest of the sort of vision of Apache Arrow to date and in the future. And he'll talk a little bit about like what we've been up to at Ursa Computing, and then now, having joined these other teams as Voltron Data. So I hope you get a chance to see Wes talk there. I know Jared was going to roast Wes, as he always does, but I'm sure Wes will have lots of interesting stuff to say there as well. So lastly, I wanted to mention before we take questions that Voltron Data is hiring, and I'll show some of the jobs we have. We for R folks, there's a senior R developer job here that might be interested in applying to. We're also just opening, we have jobs across a bunch of roles. One of our goals continues to be to support the increased deployment of like Apache Arrow open source solutions in enterprise and corporate environments and so forth. So we're hiring some support engineers and support engineering managers to help with that. So definitely check that out. And thank you, and I'll take questions.
Well, thank you very much for talking. I'll give you a little golf clap personally. Hope other people applause in the crowd as well. And yes, roasting Wes is a time-honored tradition at the conference, and it's a great show. Hope everyone attends. In fact, last year he gave a joint talk of Neil Richardson, who I think's in the crowd, and Neil's fun fact that he just comes to see me roast Wes. That's just part of it. It's such a good time because Wes is a great sport. I love Wes. That's why I give him a hard time. And yes, I made him give talks in R t-shirts. I put R stickers on his luggage just because, why not? So we do have a question about the name of the company. They love the name Voltron Data, but aren't you just waiting for a lawsuit?
I will refer that question to our in-house counsel, but no, I mean, I think the metaphor of coming together of these disparate parties coming together is certainly salient here. I can't really speak to, trademark law, but I hope not.
Captain Planet Data was taken. All right, cool. Yes, I actually texted Wes the day. I'm like, I hope, and I was like, for your hex sticker, it needs to be a picture of Voltron. And Wes is like, we want to make sure the trademark's available for that first.
Yeah, that would be a way to probably get sued. So.
Yeah, that might be pushing it too far. All right, cool. Question about, so Dplyr oftentimes will write like inefficient SQL code. How does tidyquery fare going the other direction? Is it efficient Dplyr code, or have you known some issues with the quality of it?
Yeah, it's pretty efficient because it's a simpler problem space going in the direction of SQL to R. I mean, especially I haven't tackled some of the real sources of major inefficiency, like kind of common table expressions and subqueries. Like for instance, a really smart SQL engine will do optimizations like it'll recognize that you have a subquery, but you're using it in such a way that it can convert it internally to a semi-join. And it will do things like recognize that you have two identical subqueries and then just compute them only once. So I think that as this package grows to include some of those things that it currently lacks, yes, that will probably be more of a problem, the need to optimize. Right now, given that all it's doing is converting like single select statements, it's pretty optimal, and it writes like code it's about as efficient as it could get. There's many different paths that it can take. You look at the tidyquery code. There's a really quite large number of different paths it can take to optimize. Minimize the number of different Dplyr verbs that are being called. Yeah, I know that Dplyr, well, it's gotten better. So early on, like it had very little in the way of optimization, and today it has some sort of static optimization, but nothing like dynamic optimization. Like a system like Apache Spark has just incredible runtime optimization that the Dplyr can't achieve. But I know that's an interesting subject that Hadley has like put out some calls for folks in the past to contribute if you're interested to make Dplyr more efficient. So yeah, certainly, I'm sure that's still something that the folks at our studio would love if folks are interested in contributing to make it more efficient.
Sure, yeah. So now there's a colleague of mine who knew like a Redshift very well, and he just couldn't quite get the Dplyr queries to be as good as what he wrote. But again, he knows Redshift a lot better than I did. So for me, the Dplyr is already a big heads up.
Yeah, well, I mean, one of the things I've seen people do is, they call that show query function, and then they do some manual tweaks.
Yeah,
not really a clean workflow, but it gets you most of the way there.
Definitely done stuff like that before too. And you mentioned about how like a lot of SQL engines automatically optimize the code. So would you be able to benefit from calling either SQL explain or maybe copying the parser from something like Postgres? Would that help you figure out the optimizations, and then that's built the parsed out expression? You could then deplyrize it after that.
Oh yeah, for sure. I mean, as I mentioned, this project was not an attempt to create something like an optimal SQL query parser. One of the reasons that I broke this into two parts, tidyquery and query parser, is because most of the opportunities for optimization and efficiency gains come in the query parser piece. Currently query parser is a pure R query parser. That's sort of a nutty thing to even try to do, frankly. We could easily make something that provides exactly the same functionality as query parser, but uses something like Apache Calcite, which is like a very widely used sort of SQL toolkit written in Java to parse the SQL and then run optimizations on it and then emit some kind of abstract representation of it. There would be work though to do to convert that into like an abstract syntax tree or an unevaluated R expression that R could easily understand. So I took a shortcut here, but I broke them up into two pieces partly so that if someone was interested in optimizing the query parsing piece, that there was definitely room to do that. So yeah, for sure, there's lots of ways this could be made faster.
And Ismail, you just said it, and I was actually just thinking I wanted to ask you, is there an abstract syntax tree for SQL the way there is for R?
No, there's not. It's dependent on specific database engines. I mean, yes, like each database engine would have their own like AST they would translate the SQL query into, but and also projects like Apache Calcite have given some opportunity to standardize that. So if you want to create a query engine, but you don't actually want to do the parsing of the string parsing part of dealing with SQL, Apache Calcite is a project that can help you there. However, when you're getting down to the level of like a physical plan that represents like how the query engine will actually perform the work, there's no like standardization from project to project. It seems to be like very internally dependent on like just which SQL engine that is. And that's something we're interested in understanding with this like compute intermediate representation project in the Apache Arrow project is like, can we standardize some of that across databases so that if you do want to say create a high performance engine, you don't have to solve all those problems yourself and you don't have to reinvent the wheel for what is that abstract representation you should use to store the logical plan or the physical plan. So yeah.
Okay. We just had a question. This is something I think a lot of us can relate to. This person has trouble filtering and grouping date values with Dplyr, and I have trouble doing that with regular Dplyr. Does tidyquery translate date functions from SQL?
Yes, some of them. The piece of it would be query parser that would do this, and the piece of query parser that translates functions is actually the easiest to understand and contribute to part of query parser. You do not want to look at the part that translates like between. Between is this like 3-operator function that does not map cleanly onto anything in R. You don't want to look at the part of query parser that deals with is not null expressions because they're very hard to translate into something that the R parser interprets as R code. But the part of query parser that translates simple functions that take arguments on the right is very clean, and I have definitely translated a bunch of datetime functions to luberdate equivalents. So if you keep that in query parser, if you set that tidyverse equals true argument, which tidyquery does, then it will put out some luberdate functions and string R functions as well. But yeah, let me know, open an issue, or if you're interested in contributing, absolutely open a PR. If there's ones they're missing. Another factor that's a little tricky though is I'm not targeting like one specific query dialect here. So, for the most part, we're not going to run into collisions between different ones, but there are some cases where like there'll be one function with one name and like Postgres does something totally different than say MySQL on that function. But generally I'm trying to sort of target this like nexus of like MySQL, Postgres, SQLite, Hive, Impala, Drill, things like that. So yeah, if you have functions that are sort of in that general universe that you'd like to see implemented or like to implement, go for it.
You mentioned if you do tidyverse equals true, you'll translate some of the date stuff to luberdate. What do you do if tidyverse is false with the date stuff? Because base-r has some tough date functions.
Mostly give up. I mean, yeah, in a few cases, I try to do something about it, but yeah, mostly, frankly, give up. Yeah.
POSIX
It-
LT comes back, right?
yeah, yeah. There's a lot of just non-equivalences where you simply can't do something without like having to write like ad hoc code, and there's no ability to like define an inline function or anything like that here. So yeah, if you look at like inside query parser, there's a specific object that stores all of um, the general functions, and then there's another object that stores all the tidyverse relevant functions. And it's like the tidyverse list is long, so there's a lot that it can't do without that tidyverse thing. But again, query parser, when it uses it, always does the tidyverse translations. And I think it'll be rare that people use query parser without tidyquery. So
Is
yep.
that the default tidyverse equals true?
No, it's not, but it is if you use it through query parser. So again, most people use it through query parser. When you're calling that query function, you always will get tidyverse translations. Yeah.
Okay. And like you had trouble with between, and I assume like, there's a dplyr between function. I guess the hard part's identifying between.
Right. The hard part is just dealing with the syntax of SQL in those cases where it doesn't, it's not analogous. Yeah, the semantics of SQL between and dplyr between are the same, but the syntax is so radically different that, there's a lot. So some of the work that query parser has to do is really quite hellish. It's like it has to move ahead character by character, one step at a time, and then keep track of like, are you inside a quoted string or not? How many parentheses are enclosing the position we're in right now? Are we in, well, it needs to know what clause we're in, of course, but then it needs to understand, like, are we in some sort of like construct that doesn't use parentheses? And so like is not null expressions and between expressions and things like that are just hard because, you have to deal with all that complexity of like just translating into something that makes sense to R. Yeah.
So you said between is tough. How about a case statement?
Yeah, that works too. That I should have mentioned that. That was probably the worst one of all. Yeah, but it works, but quite difficult to implement. Yeah.
Fair enough. I had a feeling that would be a tough one. Okay. And there's something that SQL does, but Dplyr doesn't, and that's inequality joins.
Yes.
How do you handle that?
I have not attempted to handle non-equijoins. Yeah, I wouldn't have an answer to that because I'm sort of by definition limiting this to what Dplyr can do. And there's many examples of this actually. When you look at some of these like sort of OLAP style SQL queries with things like group by with the roll up in them, you very quickly run into things that Dplyr doesn't support, and that like Hadley and the other folks contributing to Dplyr have just said like, unless someone else really wants to like take this on, we're not terribly interested in adding some of this stuff to Dplyr. So yeah, I mean, extend Dplyr is the only real solution there. Otherwise, we're kind of stuck with it. Yep.
I think non-equi joins would be a huge addition to Dplyr. Something a lot of people want. I know like there's packages, I think like Emily Robinson's like funnel join has similar functionality to that. And she does something in the back end to like compensate for Dplyr not having it. But I think that's the only one I know. And I think maybe fuzzy join by her brother David also might do something similar. But again, it's not built into Dplyr. It's all things compensating for it, so it's tough.
Yeah, I mean, the thing is that it's fairly straightforward to write like a really naive and efficient representation of a non-equijoin. You just do like you just do a complete like cross join, and then you just filter the result. And that works fine if you're doing small data, but it's completely impossible if you're dealing with large data sets because you just multiply them. So yeah.
Yeah, I get that. I get that. This is not a question, but for me, a comment. I really like the way you pipe data into query instead of using from. That's pretty cool.
Yeah, I thought that would be kind of a trick people would like. And yeah, thanks.
How does that work when you do like you did in the middle of a pipeline? You just piped right in. Do you just leave out the from, or do you do like from placeholder? I'm not sure I caught that.
Yeah, you just leave out the from. Yeah, you just totally leave out the from clause. If it's there, if you attempt to pipe in data and you include the from clause, it errors and tells you can't do both.
Okay.
So you leave off the from clause. Yeah, there's, one of the interesting things is that if you look at SQLDF, which I have, just a ton of respect for all the work that Gabor Gertendiek has done in that package. It's got some neat ideas for like substitutions or like sort of variables inside the query
Yeah.
string, where you can like parameterize part of the string. I haven't attempted to do anything like that either, because I figure that if that's really what you want, you'll just do that sort of outside the query string rather than in it. But yeah, certainly there's like opportunities for lots of interesting things like that. But yeah, right now it's just leave off the from clause.
And so it'd be like select columns, group by, whatever. Like it'd just be absent.
Exactly. Yeah. And some people sort of complain about in SQL, if we were writing a SQL select statement in the order that it's actually processed, from would come first.
Yeah.
It doesn't, but yeah. So you have to leave it off in the middle, which feels a little strange. Yeah, and of course that piping in data from the left doesn't work if you want to perform a join, because then there's no way to like pass one thing in there. So that only works in the single table query case.
Still very nifty. I really like that. All right, cool. I'm gonna give everyone just a moment to see if there's any like last minute questions sneaking under the wire here. In the meantime, while we wait, and I'll speak slowly for people to ask their questions to drag this out a little bit. Before I even thank Ian, and I will certainly do that, so I'll reiterate some of my announcements while we wait for people if there's any last minute questions. Next month, it's an R-fold month. We're going to have a meetup for September 1st or 2nd. We're going to have workshops September 1st. We're going to have the conference September 9th through 10th. So a lot of things all happening in early September. And after that, we will continue in October, November, December in our regular programming. If you have a job you're looking to fill, go to the job postings channel of the NYHackR Slack. If you're looking to get a job, go to the job postings channel of NYR Slack. This way you can find a job that someone posted there. I hope everyone has had a good time, and it seems like I'm looking at both Slack and Zoom. I think we've had all the questions. So I'll just say I hope everyone's having a safe end of their summer, and I look forward to the next few months. Again, everyone, we're definitely going to be virtual for the meetup in September, and we'll see about the conference within the next week or so. We'll have a determination, and subsequent months of the meetup will also, we'll go back to in person as soon as we are able, but until then, we'll continue virtual. And with that, I don't see any questions. So a big thank you to Ian for talking about this package. I've been actually working with a client. They've been using SQL DF and it's causing memory issues because you are piping it. I'm like, let's switch you over to tidyquery. Let's do it. Let's do it. Let's do it. And I've been a big fan of this package for a few years now. So I am personally super excited that Ian came and gave this talk. It was really, really interesting. I really enjoyed it. I hope everyone else did. So big round of golf clap and a big thank you to Ian for doing this for us.
Thanks, Jared.
Yep. Everyone else, have a good night, and I will see you virtually probably or in person at some point over the next few times, and we'll do all our announcements coming up very soon. Thank you, everybody. I see there's a bunch of thank yous for you, Ian, in the chat already. So I think a lot of people really enjoyed your chat as much as I did.
Cool. Yeah, my pleasure. Thanks for inviting me in.
Absolutely. Our pleasure to have you. Bye, everybody.